Look up at the night sky, and it's honestly almost impossible not to wonder, are we alone out here? Welcome to today's Explainer, where we're going to tackle that exact question. But look, we aren't doing this through the lens of science fiction or, clickbait headlines. Instead, we're diving into a rigorous, purely data-driven academic synthesis dated May 26, 2026. If you want to know exactly where the science actually stands right now on the search for extraterrestrial life, based strictly on verified, peer-reviewed sources, well, you're in exactly the right place. Let's get into it. Okay, let's just rip the Band-Aid right off and anchor our expectations with this defining executive summary statement. Quote, as of this review date, there is no scientific confirmation of extraterrestrial life beyond Earth. Now, you might think that's a bit of a letdown, but it's actually incredibly exciting. By clearing away all the noise, we can focus on the profound stepping stones we actually have found. Because as you'll see, we are looking at a universe completely teeming with the chemical precursors to life, and the scientific hunt is literally more robust than it's ever been. So here's our roadmap for this explainer. 1. The baseline of no confirmed life. 2. Meteorites and prebiotic chemistry. 3. Habitability on ocean worlds. 4. Disputed biosignatures and exoplanets. 5. Synthetic life and technosignatures. And finally, 6. The current state of knowledge. All right, diving into section 1, the baseline, no confirmed life. That brings us straight to this number, 0, a big round 0. This is the exact number of scientifically confirmed extraterrestrial life forms discovered to date. It is absolutely crucial that we start here. By grounding ourselves in pure facts, we build a foundation of trust. We aren't here to speculate today. We are here to look at what the verified data actually proves. And this right here brilliantly illustrates what I mean. If you look at this verified paper trail from the executive summary, you'll see that while biological life remains at 0, our findings on prebiotic chemistry are remarkably robust. We've confirmed amino acids in meteorites, complex organics on Enceladus, and carbon-bearing molecules on distant exoplanets. The universe is actively cooking. The ingredients are all there. Moving right along to section 2, meteorites and prebiotic chemistry. You probably remember the one on the left, right? The famous ALH 8401 Martian meteorite. You might recall that massive 1996 Mackay paper that proposed it showed signs of ancient Martian life. Well, while historically suggestive, current rigorous review shows those features actually have possible non-biological abiotic explanations. It's just not confirmatory. But contrast that with the Murchison meteorite on the right. Verified papers like Koga's in 2024 provide rock-solid, definitive evidence of extraterrestrial purine nucleobases. Murchison absolutely proves that the prebiotic building blocks of life are being delivered from space, even if it doesn't prove life itself. Which brings us a bit closer to home. Section 3. Habitability on ocean worlds. Check out these validated source tables. What you're seeing is how the academic synthesis painstakingly corrects source records and DOIs, literally removing invalid citations to build absolute trust in what we actually know about Enceladus and Europa. This level of intense scrutiny, this is what separates true astrobiology from mere guesswork. So breaking down these key findings, we see some highly distinct geochemical profiles. Take Saturn's moon Enceladus. Sources from 2015 to 2018 completely confirm hydrothermal activity, molecular hydrogen, and complex organics blasting out in its plumes. It's a wildly promising, habitable environment. Then we have Jupiter's moon Europa. Recent 2023 science papers confirm endogenous carbon dioxide ice and surface salts that are totally compatible with an internal ocean, though notably they haven't detected plumes there yet. The crucial point here is this. Both of these ocean worlds are potentially habitable in a chemical sense, but neither has shown definitive biomarkers of actual organisms. All right, let's zoom way out for section 4, disputed biosignatures and exoplanets. We've all seen the crazy headlines claiming we've found signs of life far away, right? Well, whenever you see those, you have to run them through this exact scientific gauntlet. Step 1 is an initial signal detection, but that immediately triggers Step 2, intense scientific debate. Step 3 requires rigorously controlling for false positives, checking instrument statistics, and refining atmospheric models. Only then, and we're talking maybe years later, can we move to Step 4, future confirmation. A preliminary signal is a great reason to look closer, for sure, but it is never immediate proof of biology. Let's actually look at 2 famous examples of this process in action. Back in 2020, phosphine was reported in the clouds of Venus. Huge news, right? But subsequent rigorous analysis categorizes this as a debated detection, and further studies heavily question if those clouds are even habitable at all due to extremely low water activity. Meanwhile, the exoplanet K2-18b is incredibly exciting. The James Webb Space Telescope detected carbon-bearing molecules, suggesting it might be an ocean-covered Hycean world. There are even proposed signals of dimethyl sulfide, or DMS, which here on Earth is strongly linked to life. But, as the 2025 Madhusudan paper clarifies, these are just candidate signals. They require confirmation. Extreme scientific caution is the name of the game here.
Section 5. Synthetic life and technosignatures.
First off, let's make sure we're on the same page with the term abiogenesis. This is the original evolution of life from non-living inorganic substances. It's the spark, and it is so crucial to understand this process has not yet been completely replicated in a laboratory setting. Looking at this source table on synthetic life, we can see some wild milestones. I mean, we've got Gibson's 2010 work on bacterial cells controlled by synthesized genomes, all the way to the rapid reconstruction of viral genomes in 2020. We can actually synthetically construct DNA to control existing biological systems. That is a massive scientific achievement. However, editing or controlling a cell with a synthetic genome is not the same as creating life from scratch out of raw chemicals. And more importantly for our explainer today, synthesizing genomes on Earth absolutely doesn't prove that extraterrestrial life exists out there in the dark. Let's tie it all together in Section 6, the current state of knowledge. I want to point you directly to the source document for this. This right here is the official state of knowledge from the verified synthesis. It categorically separates the data into high confidence, suggestive, or debated, and not confirmed. This proves that our conclusions today aren't just opinions. They are firmly grounded in peer-reviewed, heavily scrutinized scientific data. So what do we actually know for sure? What can we celebrate with high confidence? The universe is undeniably, unequivocally teeming with the chemical precursors required for life. We have confirmed extraterrestrial organic matter and nucleobases raining down in carbonaceous meteorites. We have absolute proof of hydrothermal activity in complex organics erupting from Enceladus. We see carbon dioxide and salts heavily hinting at dynamic internal chemistry on Europa, and we are definitively detecting carbon-bearing atmospheric molecules on exoplanets light years away. The stage is perfectly set. But to maintain absolute scientific integrity, we got to be honest about what remains not confirmed. Because despite all those incredible precursor ingredients everywhere you look, we have zero confirmation of active extraterrestrial life today. We have no confirmed fossils of past life beyond Earth. And despite decades of searching, we have no validated technosignatures from extraterrestrial civilizations. The silence out there remains absolute. Which leaves us with this final, lingering thought to close out our explainer. We know with extremely high scientific confidence that the chemical ingredients for life are literally everywhere in the cosmos. I mean, the universe is a vast, bubbling cauldron of organics, subsurface oceans, and dynamic atmospheres. So the profound question isn't whether the building blocks exist, it's whether those blocks require a rare 1 in a trillion miracle to assemble, or if it's just a matter of time until we finally see them spark. Thank you so much for joining me on this deep dive into the data today. Keep looking up.